Okay, so we know in the future world we need to have 5G, right? And we need to have many talents to help to control, to construct the network. Okay, even though you are not working for the telecom company. So there's more information in the video. Okay, these are the examples. Like here, now is the year 2020. No. The video is now. Okay, but now we are in 2026. Okay, but how about 10 years, 15 years later? Just think of now is 2026. 50 years ago is the year 2010, right? In year 2010, what GSM system are you using? 3G, right? It's much slower. Okay, so at that time, I think there's not many vehicles can connect to internet, right? Okay, I mean, if we look back to the 2010, 2010, right? So the current, how can you know the future's standard? How can you know the 6G? Okay, I want to tell you the information is for 4G, because the frequency is much lower. Right? 5G is much higher. So anyway, the coverage of the radio station is much smaller by 5G. But 4G has a wider the radio coverage range. Okay, so most of the time, you may connect it to 4G. Okay, but if you get into the 5G radio range, you may have a faster connection speed. Okay, so that's the current, the network. So there is a terminology called SA and non-SA, non-standalone and standalone. Okay, standalone, SA means pure 5G. Okay, and non-standalone, non-SA means it's mixed 4G and 5G. Okay, we will talk about this later. Okay, so that because we are using 2 generations network, so that makes things a little bit complicated. Okay, like I speak Mandarin, you speak different language, right? But we use English, right? So it sounds like that. We have to unify the language we are using. Okay, but however, once you are developing the technology or the communication protocol, you have to consider the last generations. How can you communicate with these car language issues? Because, like I said, if we are going to develop a smart city system, we are going to have a smart, traffic controlling. But a car, it cannot access to the radio roadside unit. So what? It will become the problems in the system. It may cause some accident because he cannot show his information to everyone else, the other vehicles. Okay. Anyway, what are the main features of 5G network? So 5G network commit to provide mass connectivity. Like I say, all devices have to link to internet. That's the meaning of the IoT, right? Everything get on internet, not just your cell phone. Your cell phone is one of the IoT, but just much powerful. That's all. We all rely on the cloud service, the resources behind. Okay, so anyway, you need a connectivity. So no matter you are, gamer or you are using VR, AR for your work, or the machine need to communicate the network. The 5G will try to cover all this. Okay, so there is application like the self-driving car and the mission critical applications. This requires low latency, something like this, and the smart city building voice. Okay, so how can you handle the massive machine type communication? Like I say, at a factory, right, we have many machines. Every machine want to transmit data. So how can you handle this? And ultra-reliable low-latency communication, right? You need to have a quicker response. You need to have quicker. So here, based on the radio, a video we just saw, right? There is a vehicle to X, right? Vehicle to network, V2N, V2X. V2X can be vehicle to vehicles. So once you need to have a quicker response, you cannot rely on the cloud, right? So what can you rely on? Maybe far, something more closer on the radio station. So it will quicker response to you. Okay. Anyway, there's more we need to discuss in the further parts. Okay. But just summarize that. What technology, main features on the 5G? What's the difference between 4G and 5G? That's it. New spectrum. So we have a faster radios, and there's a beamformers. What's beamformers? I know probably you don't have any radio communication background, but it sounds like if we are going to have good signals, what will we do? I mean, when I was a kid, I used to listen to radios, right? So I will adjust the radio antennas to a certain direction, right? Okay, so if you are home, you living in a suburban, I mean in a rural area in the country. So you don't have a cable TV, right? So you may have antenna to receive the program, wireless TV. So you may change the direction of the radio to get a better signal, or the satellite TV, something like that. So the beamforming is like they can enhance the signal in certain directions. So there's many that they call matrix antennas inside. So they can enhance the certain direction radios. So if you call the telephone company, you say, around my house the radio, the signal is very bad. They are not going to send engineers to enhance the signal. They are going to use this to enhance the signal. Because labor will be very costly in the future. So what they do is just program this. Maybe amplify the signals. Okay. Maybe add another antennas to amplify. Okay. So that's we call beamforming technology. And the multi-connectivity. Okay, that's three first. Okay, that's lean efficient design. So lean carrier, flexible size control. Okay, so maybe you are a little confused, but just to give you example, like I say, everyone has some job to do, right? So we will assign some channels for you to use, right? But I'm the one who give you the earthquake alert or fire alert. So I may need to just have a little bit, right? Something like this. So we can define the channels to make it more efficient, right? So if I am not using the network, maybe I can give someone to use to make it more efficient. You know what I mean? Like the current 4G network, if someone already buy the channel, someone can now nobody can get in to use the channel. Something like this. Okay, so multi-connectivity, you may dig to 5G, light, Wi-Fi. You may curious say, Wi-Fi is not 5G. This is 4G, right? This is 5G. Wi-Fi is not. No. Everything will be under 5G core. Understand? So 5G cover all everything in the network in the future. So you can manage it. Bluetooth or any protocol for the IoT parts should be managed. Okay, because like Bluetooth, Bluetooth is running in 2.4 gigahertz. The radio is the same as Wi-Fi, right? So they may have some interference. So anyway, that's an idea. And the last point is edge computing. That's what I'm talking. They have edge computing. So if there's cloud-to-cloud communication, we are not going to pass everything to the cloud because it's too far away, right? So we may have something located at the radio stations. Okay, that's what we call edge computing. So we can solve the problems or commute like this. So we will be able to save the bandwidth. Okay, so that's what 5G technology provide. Okay, 这个就是 5G 它跟 4G 不同的地方。That's the differences between 4G and 5G. Okay, there is more information here. That's ready RAN and open RAN. Okay, so it's something like you have equipment, right? And then you connect to the RU radio unit, right? It can be 4G, 5G, right? And then encode and the cell side and aggregation router, edge cloud. So anyway, you may dig to the internet. There's so many things. You will construct the network for today. Okay. But what's the open RAN? Open RAN means like a free 5G core. It's free, so everyone can use. But this RAN, the radio access network, this developed by a company. For example, telephone company, Taiwan is Zhonghua Telecom, right? And the Taiwan Mobile, right? And the Far East, right? I believe most of them, they will use Ericsson or Nokia's equipment. But no Huawei. Huawei is, they are from China, coming with not our party. So where are you from? Washington? You are from Russia, you are on the other side. Okay. No offense. Okay, we are welcome all students from the world. I don't know your background, but I would say in Taiwan or in the West, it's not allowed to use Huawei facilities because of national security issues. Okay, anyway, I want to say is because Nokia or Ericsson, the equipment is so expensive. Huawei is cheaper, so why it's so popular before? Okay, but now the Western country consider some national security issues, so they banned. At least the U.S. President Trump banned the Huawei equipment. Okay, anyway, I want to say is that telephone company, they want to have a stable system, so they will prefer to use the expensive one equipment. But if you are going to build a private network at your factory or at your, like Taiwan, we do have, like Formosa Prestige company. It's a very big company. Or CPC, petroleum company. They do have a very, very big campus. Even TSMC, I think everyone knows TSMC, semiconductor company. They need to have a 5G network, right, for managing this. So, but I believe TSMC, they will use the expensive one, okay. But if you want to save your money, you may consider to use radio devices from Nokia, Ericsson, right, or other third party to lower your cost. Okay, but the back end, mostly they are IT equipment, right? It doesn't have to be buy from some prestigious company. Okay, anyway, I just let you know there is another option for this. Okay, and next is I just watched recently. It's about 6 minutes. Now, everyone talk about AI, right? But if you look back to the 3-4 years ago, not many people mentioned AI. Okay, but we know the 5G network looks quite complicated, right? By the video we just saw. So are you going to work with that? No. Why? You want to have something like a ChatGPT to tell you how to set it up, right? So in the future, if you have AI, you may just tell the AI, I do have hundreds sensors. It's going to link to the internet. I have an OPC server, 10 OPC server. I have 20 machines. Okay, require Wi-Fi, something. You just give me this information, and it will automatically to create the network for you. That's the idea. Okay. I think everyone uses ChatGPT or Gemini, right? Okay, you have a question, then you will respond, give a response. Okay. So in the future, you will have the app from AI. Okay. You want to watch this? Maybe watch 6 minutes.
The term AI RAN was coined by the AI RAN Alliance, and it refers to the tight integration of artificial intelligence within the radio access network. This includes use cases such as AI for RAN, which is the integration of artificial intelligence to improve the operation of RAN functions. But it also explores potential use cases for operators where the radio access network can be used as a platform to run AI workloads or to run AI applications and services at the network's edge. So the AI RAN Alliance consists of a number of key founding members. There are additional stakeholders involved now, and the ultimate goal of the AI RAN Alliance really is to encourage the integration of AI, to explore use cases for the integration of AI to improve RAN operations, but also this idea that we can expose the RAN itself as a monetization opportunity, as a compute platform for other third parties who may wish to run AI applications or workloads at the RAN at the network's edge. So moving on, we can take a look at some of the key use cases. So I've mentioned already this concept of AI for RAN. And this really is the kind of traditional idea of where we think of AI as improving the operation of the RAN, be this through machine learning models, for example, that can analyze historic data and select optimum parameters for the radio access network to operate on based on network conditions. It could be related to things such as the efficiency of radio resource management. It could relate to things such as predictive maintenance, interference mitigation, load balancing, handover optimization, and so on and so forth. So really anywhere that we can use AI to improve the actual operations of the radio access network itself. Now, the next two use cases are a little bit different, and it really is about creating that shared infrastructure platform that I've alluded to already. So with AI and RAN, this is where we have a single unified platform that is capable of running both RAN workloads, so the things that we've mentioned already, but also providing resources to run AI workloads alongside. So what we might see is that during quieter periods on the RAN, for example, so overnight where there are a lot less users interacting with the network, well, actually we can allocate resources to AI workloads. These could be from third parties, so it could be to do with things such as model training or inference at the network's edge, for example. But it could also be that we're running workloads, AI workloads, related to perhaps analytics in the core network. So the idea here is that we can have a single unified platform that can run multiple different types of workload. AI on RAN really takes this up another level in terms of we're creating a platform to host applications and services, so fully realized applications. So not just AI workloads that may be part of other systems, but actually running things such as immersive multimedia applications at the network's edge, for example. And by tightly integrating this within the kind of RAN compute infrastructure, we can ensure that we really drive down latency levels. And by bringing these services closer to the user's attachment point on the network, we can ensure that they have the optimum quality of experience, so such as generative AI systems, or indeed to offer. So AI for RAN, some of these we've mentioned, but we can use it for things such as channel state information, so we can estimate this. We can use it for modulation, forward error correction. So really any kind of technical operations of the RAN, we can utilize artificial intelligence and machine learning models to optimize and to improve efficiency. With AI and RAN, as I say, it's about this kind of common infrastructure, this infrastructure as a service, and it can be used to run multiple workloads, whether they relate to the RAN itself. So this could relate to things such as generative AI systems, model training, for example, for core network functions. It could also run workloads related to private 5G networks, for example. So what we see here is a combination of both RAN and separate AI and machine learning workloads. And then finally, just to summarize again, AI on RAN really is about those applications. So things such as multimedia applications, but we might also see this deployed in the context of industrial media applications.
Okay, anyway, that's most up-to-date technology. Okay, so we are not going to teach this, but at least you know the AI algorithm can help us to improve the RAN performance. Okay, and the common functions you can run AI and RAN the workload, and enabling AI service on RAN at the network edge to increase the operation efficiency. Like in the beginning, we talked about the 5 main features, right? So that's how AI can help the 5G network. Remember this? This, right? So all of that is trying to use AI to improve this. That's a video I just saw a few days ago when I prepared in the class. Okay, I think that's pretty neat. But I think it's good to know these new technologies. Okay, so if you are doing the research, probably you can take time to take a look more relative information. Okay, so finally, we come to the class introduction. Okay, the textbook. I think you may be able to find the syllabus on our system. Okay, so in this class, it's very simple. I think I have been told. And for hands-on in this class, we have hands-on. And but for getting more familiar with the real 5G world, so we are going to visit the Smart City Summit and Expo on week 4. Okay, that would be March 17th. Okay, Tuesday afternoon. Okay, so you may find that you mention how to get to the exhibition hall. Okay, I will meet you there. We apply group tours, so we will have a tour guide to introduce some work. But this is a smart city. It's not dedicated for 5G. Okay, so not everything related to 5G. Okay, the grading, I'm going to tell you the grading rules. Okay, I already right here. Basically, general performance. I mean, you just come to class on time. Okay, submit your homework. We may have some easy quiz. That's all. That's for evaluate your performance in the class. And then for midterm, 2 or 3 students make a team, and you may give a proposal. Okay, we will also give some quiz based on the class. But don't worry, all of this was from some materials. Okay, just I think it's multi-choice, single answer, something like this. Okay, 1, 2, 3, 4, you choose, no, A, B, C, D, you choose A or B or C. Okay, like 5G, 4G, if Wi-Fi including in 5G, yes or no, something like this. Wi-Fi include in the 5G, right? Yeah, everything will include, something like that. Final, you will work with your teammate and then use the tool we introduce to build a network. Okay, so I will suggest you to read a paper to have some relevance and then build your project. Like this. Okay, so I will, for hands-on, I would like to introduce our class TA, Vanel, he will help to help you for that's the textbook and the literature. And that's before we teach this, but now we only teach the hands-on. So you want to use PowerPoint or use PowerPoint? Okay, introduce. Okay, that's Manel. He is my PhD student.
Good afternoon, everyone. I'm Marinel, and I will be assisting everyone with the labs. Right. So for this year, this is the first year that we're using this framework, Free 5GC. So Free 5GC is a very popular framework in academia, and also it is being deployed in industry. So we figured that it covers the best of both worlds. So if you learn this, then there's a good chance that you can use this in your jobs, basically, right? And one of the main tasks of the industrial manufacturing department is to have industrial academia collaboration, right? So ideally, whatever we learn here should be applicable in the industry. Alright, so most of the materials that we will be using can be found online, and since it's how should I say, it's a common framework, you can find a lot of tutorials by doing a few searches, right? But in case you need specific help, right, or if there's something that we explain and it's not clear, you're free to send a message via Moodle or contact us directly in class. Or you could just come to the center and you could inquire when it's when it's possible for us to have a meeting. Right? So if you want to use 5GC, a free 5GC, you first need to install it, right? And there are several methods of installing this. So one of the recommended methods is to use Docker. Right? Docker is very common nowadays, and Docker is similar to a virtual machine that once you download Docker, it comes in a package, but it's different in that it's not, it's a lot more lightweight, right? And if you learn Docker, you also learn how to use many other common frameworks outside of what you're going to teach in the class, right? So the material here, you can find that if you go to the homepage of free 5GC, right? So we're not going to cover most of this right now. We're going to do it again next week. So this week is just the introduction, right? Because who knows? Some of you may not like this course, and you're like, I don't want to do this course anymore. Just drop this course, right? So why do this right now when you haven't really fully made up your minds yet, right? So let's see. Okay, I'll show you where you could find this information. Oh, by the way, how many students here know how to use Moodle? Moodle. Have you heard of Moodle?
Moodle? Do you know Moodle system?
Okay, you know Moodle? If you know Moodle system, if you do not know Moodle system, the Moodle system, please raise your hands. If you don't know, it's fine. If you don't know.
All materials we will upload to the Moodle, so you will be able to access easily.
Okay, so I think everyone knows Moodle, so I will still go for it quickly though. Let's see. For the midterm, we'll be using Moodle for the midterm, or we'll be using this platform. I think Moodle, right?
No, well, we will take some quiz from here, so it's not difficult.
Yeah.
I mean, the exam.
So the exams will be online, right? The exams will be on Moodle, using the Moodle platform, and if there's any deviation from that, we'll let you know. Okay?
I'm not going to ask you, the abbreviation for some terminology. Oh. I won't ask you why is the PRCA, something like that. It's impossible for you to remember. Or maybe 3GPP. Why is 3GPP?
Well, I think it will
it
will depend on how frequently we come across the terms, right? Maybe some terms that we will always come across and it will be easy to know, right? And there are other terms that's more obscure, right? And we all know the questions that give us the most trouble are those questions where you just encountered the word maybe like once for the whole semester, and they give you a 5-point quiz on explain this topic, right? And then you're like, I don't know what this is, right? So that's not going to happen. Most of the content will be based on the material that goes in class, right? So whatever that's in the quiz, you should know it, right? It's not a difficult quiz. Well, quizzes rather. Now, let's see. So this here is mostly for the students. Don't do this, right? This is just like
No.
we'll go through this in class.
This is just an introduction. So it's about 3 to 4 hours. We hope you can watch this at home.
Yeah.
Because that's they offer.
Yeah.
They offer this course, so you can have a quick idea about the whole training lab. Right? Yeah. So you can know it and go through some video, answer
Yeah,
some
so
quiz, but
We will give you the instructions on how to carry out that task next week. Right? This week is just to give you a flavor of what you can do with 5G, right? The 5G frameworks. So we have, I'll just go through this quickly. So we have lessons, then you have the tutorials. Yeah, so the tutorials, those can be found on the GitHub, right? And they are well documented. Also, I will introduce to you a few other tools that can be quite useful, or actually they're used quite often in academia. And you could also use it in your own industry, right? Well, I mean in industry, because there are a couple of videos that have been created by very reputable people, and they use those same tools, right? So I will introduce you to a few of them. So these materials are more like, how should I say, references that you could refer to outside of the lectures. Right. Now, what I want to show you in particular is a very common framework, I think, that might be of use to you. So there's a framework called Mininet, right? Right, so Mininet is useful for creating virtualized networks. And you can use Mininet to simulate 5G networks, right? You can, many of the functionalities of 5G can ported to Mininet. Right? And Mininet is also quite easy to get into. So there's a lot of documentation on it. One of the most important things is not how effective the framework is, but how well you can find the documentation. Maybe not so much right now because we have, well actually I think maybe even more so right now, because even if you use like LLMs like Gemini, ChatGPT, sometimes they can give you incorrect information. So it's always nice to have examples that you can work from. So this is one. So last year we introduced we introduced some hardware that you can use to simulate a 5G network, right? At least in part. We don't have, well actually we do have the hardware for the 5G, but we don't have access to it, right? The telecom companies are running that piece of hardware, right? Yeah, but it is quite possible to simulate your own 5G networks with hardware that you can buy off the stores, right? And we have, for example, we have.
Actually, you can apply a SIM card for your private network. I mean, you can call Chunghwa Telecom, and they can have a SIM card which can be used for constructing your private network. But it's too expensive. I don't have budget for that. So in this case, we may only simulate. But if you go outside on the roof, we do have a 5G, 4G antennas.
So if you go to the tested hardware, for example, you can find hardware that you can use to create your own 5G networks, right? But if you're willing to go outside of those supported lists, basically, if you can find hardware that emulates some of those features, you could buy the hardware at a cheaper cost, right? And it will work just as well, right? For, I would say, legal reasons, I can't really specify what hardware it is, but yeah, they do exist, right? So if you do your research, you can find that, and if you're really interested in going that direction, like creating your own networks, there's two things that you should bear in mind. The first one is that you should be aware of the, what they call it, the wireless laws, basically the transmission laws in the country. Every country has transmission laws that you must abide to, right? For example, if you transmit on certain bands, you can get sent to jail, right? And you need to know what frequencies that you can transmit on. Receiving, anyone can receive. No one really cares, right? That's why there's encryption. But transmitting is very important, because if you transmit on the wrong band, you can cause interference, and the interference can land you in jail. That's the first one. The second one is the hardware that you get. Sometimes, how should I say? You need to agree to the terms of the hardware, right? So if you buy the hardware, you have to use it according to what you're allowed to, right? Yeah, and the other, I think that's it mostly. For the other aspects, we'll go through it throughout the semester. Alright, did I miss anything? No. Yeah, so, one more thing. So, last year we did a demo on something called software-defined radios, right? So, the software-defined radio is basically the hardware that you can use to emulate the 5G, the 5G hardware, basically. So if you are interested in trying to use that hardware, we do have a few pieces. You can ask to borrow it. It's fine. Yeah,
And the PowerPoint that we do have this information. I still keep the file, but okay. Probably it's about time to take a break again. Okay, so just give me 5 more minutes to finish this. Okay, thank you, Cornell, to introduce the hands-on. Okay, so but we know the technology that's a textbook. You don't need to buy it. I think you don't need to buy it. You can find mostly information in our hangout. Okay, so that's the chapters we are going to go through, and that's a reference the task I took. Okay, so as I say, it's not free courses, so I can only share some information with you. And if you are going to be more professional, I would like to suggest you can take the 5G network courses. Okay, so this class is just beginning to invite you to the 5G network, because once you are going to look for jobs in the future after you graduate, there's so many. Now the highest salary can be semiconductor engineer, right? In the future, maybe AI engineers. But I didn't know what you prefer to do. But for 5G engineer, what I know is the salary is pretty good. But it depends on how much do you interested about this kind of job. Okay. So target audience. Okay, the hands-on. Okay, before we do have the kickoffs to have this information, but from this year we decided to use the free 5G suite. Okay, so we are now going to continue this. Like this GNS3 is, if you are studying IT, probably you know this is way. Okay, but the 5G including 2 portions, right? First part is radio. The other part is the network. Okay. So the network engineers, most of the engineers, they will use this to develop their network. Okay, so this class is the same. In the first 3-4 chapters, we were talking about the radio part, or we call RAN, Radio Access Network. But then we'll go to the ground, right? That will be internet. Okay, we also talk about the 5G toolbox before. Okay, so also some devices, but I still keep this information, but we are not going to go through this year because we don't have time, I think. Okay, these devices were not very expensive, but however, I want to share with you is the real components of which is today. So you may use dongle or router or the computers with embedded 5G module or something like that. So if your lab, it's just outside of our building. Okay, you can go outside, you will be able to see this. One is for 5G, one is for LTE, and you know why? Because we are running with NSA, non-standalone network. Okay, so and the last on the edge, NEC. Okay, we borrow this from AEON company, but now we return after our research project finished. We return it. So now we don't have this. Okay, anyway, we will visit the smart city, Summit Export, and I already applied a group to it, so you may. I would suggest you apply a electrical ticket permit first, in case you are late. Okay, grading, and what we are trying to do is like this. Okay, you may refer something like this. You will build a network. Okay, that's a radio station, right? So you may access some resources, right? And then you are going to monitor the data transmissions. So you will be able to find out when is a traffic jam, how to make your network more efficient. Okay, so that's it for the introduction. So, any questions for the class today? No? So all your information is here: introduction and hands-on and the technical update and grading. Okay. And okay, so now is 3:21. So in this class we have 3 hours. So let's take a 10 minutes break and come back. 3:30. So when we have break, I will set the timer. Okay, so please come back in 10 minutes. Okay. Or you guys want to finish the class earlier? Since it is the first day. You want to quit? Okay, so we finish the class early. It sounds good. Okay, we don't have break. Okay, so we continue. Actually, I don't have much things to say in the last hour. I think we have been talking about everything already. Okay, but anyway, that's a schedule for what we are going to do in this semester. The chapters, the read, and the lab. Okay, the lab 1, lab 2, lab 3, lab 4, and after midterm, I would like to have you to focus on the project, because probably we are not going to go through everything here too much. We just focus on the things you need to know. I mean, to develop a small project, not a big project. Okay? So that's what we are going to go through. Okay, and I think all you mentioned here. For the last hour, I would like to tell you is this compliment. Compliments here. Maybe I will click on this. Huh? Okay, so since you take the 5G class, right? So it's good for you to know, what's the spec of your 5G cell phone, right? So the telecom operator frequency is we just mentioned 5G new radio. For today, you probably just need to know that's a new radio. Okay. And the 5G SA, standalone, and independent networking. So that means the network is running purely with 5G. And NSA, it means combined LTE and 5G and 5G. So it's non-standalone. So you can prospect the network of the NSA will be more complicated. Right. Okay, so if you are going to buy a cell phone, you may want to know, if you are going to subscribe telephone packages, phone package, you may want to know their channels. Sometimes some people may say, oh, Chunghwa Telecom is a big company, the signal is better, right? And the Taiwan Mobile, wow, they have a more advanced equipments, okay, something like this. But actually, they are 5G, they are running with different frequency. Where their licenses are different. Okay, so mostly we use N78. You don't need to remember all details, but at least you know 5G including many different channels. I mean frequency. So that's why different companies they can provide different levels of service. I mean quality of the communication. Understand? So sometimes, if you know this, you will not complain about why Chunghwa Telecom charges so much. Because they pay more money to the government. Okay, anyway, usually the company, they will tell you where has the 5G signals. Okay, so you can check this website. Okay, so if you check in the website they provide, they will tell you the signal quality in this area. Okay, so you will be able to, like this is our school, Taiwan Tech. So, you know, in the front gate of our school, there is a IP building, right? So you will go to check the IP building, international building, the top roof, there is a big radio tower, right? Okay. So you can see the signals. That's where we are now with our center. So you will be able to see the signal strength. So if the signal is not good enough, you can call them. They will enhance. But our signal is very good. Why? Because outside we do have a small cell. You don't know what is small cell now, but later you will be able to know. Okay. Small cell is something like to enhance your local signals. Okay, if you go overseas, sometimes you may find out your cell phone doesn't work. What happened? Because some cell phone just does not support the channel. So the cheapest cell phone, they may have more limitation like this. I think this one can be cheaper. Because you only support 140. This one is only for like some other text message. So this is for like normal use. NSA now you know is being non-standalone, right? Cover 4G and 5G. So now you understand what it is. And also ENDC, well that's a dual connectivity. What that means is dual to channel. We will explain this more. But however, once you know this, you know why you don't have a good connection. One is telephone company. The telephone company need to provide good signal, right? The other things is your user, we call UE, user and devices. So Huawei, HTC, ASU, ASUS, like this. So you need to know there's more details. Okay. However, that's devices we use in daily life. Okay. But the question is that if we are going to, like you, maybe some of you are doing research with 5G. Because we have some students from electronics engineering departments. Okay, their lab are doing some research with this. Okay, so they may need to study this. Okay, so you need to have devices which provide 5G module, right? So that's information for you to get these devices. Okay. So that's what you can use. Okay. In our lab, we also have this Raspberry Pi 4. Okay, so if you buy these, you can have a Raspberry Pi and you need to buy a module. Okay. 4G is cheaper, but 5G is quite expensive. Okay. So anyway, you put this. So once you are going to put your machine, for example, you have a CNC machine, you want to put this machine online, so you can have these devices that you can conduct your experiments, like something like this. Understand? Okay, so, but the problem is you can buy this device, the module, but these can be only used in China, not in Taiwan. Okay, because the channel, the frequency are different. Okay, some information is about software for simulation, which and for network analyzer. Okay, and some information just for students who are doing research with 5G. Okay, so I think that's all for today's class. Okay, so let's end the class here, and all informations you should be accessed from our Moodle system, or where is Moodle? It's here. Okay, so that's all I want to talk. And there's some link, some reference here. You can go to check. So we'll finish the class earlier. Any question? If no, thank you for attending this class today.
So for the midterm, do we have to propose our project in class?
Oh, yeah. But you know, two to three students make a team. So you are not alone. I mean, you just work with your teammate and tell us what are you trying to do. But in the schedule, I'm not sure if we I may have some adjustment, but for now I will prefer to separate them because this year, since we have more students, now we have about 10 students, right? So it may be 3-4 groups. Okay, so the exam can be easy because it's just 20 quiz. So I would prefer to have maybe we have a quiz and have a one team to 2 teams to present, and then we have a proposal for next week. Something like this. It won't be very difficult. Yeah, that's it. Do I answer your question? We may do it at the same time, but we have 2 weeks. Week 8, week 9. So we may have, if you want to have 2 or you want to be alone, it's fine. I mean, you want to make a project by yourself, it's fine. Okay, so we may have 3 to 4 teams. Okay? Yeah, we do. Okay, if no question, is dismissed. Thank you. If you want to stay to talk to me or TA, you